This is S. This is R. This is Q. This is S. This is R. This is Q, and this is Q. Sorry, this is Q bar. This is Q. So this is the circuit. This circuit is equal to this circuit is equal to S. Sorry, R S Q bar. Both are equal. Okay, so here S R they given, here R and S they given. Okay, so when you are going to write the exams or MCQ question, so they will change the inputs. Okay, don't blindly goes that. Okay, so this is the inputs. Okay, this is the output. They will change the inputs. According to that, you need to write the outputs. Getting? So now we'll see the truth table of this SR NOR gate latch related thing. SR QM Q bar. 0 0 0 1 case will be there. 0 1 0 1 memory will be 0 can or 1. 1 0 memory can be 0 or 1. 1 1 memory can be 0 or 1. So now 0 0 case. So if I am giving S is 0, R also 0. So NOR gate any one of the input is high, output will be low. So any one of the input is high. Here both are low. So if Q is 0, so then what happens? This is 0 0. This becomes any one of the input is high, output will be low. This is 1. So this 1 comes here and it becomes 0. Means if Q is 0, it will be 0. Q is 0, it will be 0. So now Q is 1. This 1 will goes here. Any one of the input is high, output will be low. This will be 0. The 0 will comes here. 0 0. So then output becomes 1. Output becomes 1. Means this is, if it is Q is 1, so it will be 1 1 0. This is memory state. Memory state. So now coming to 0 1 case, if you observe this 0 1 case, so now S equal to 0, R equal to 1. Any one of the input is high, no doubt output will be low. This will be 0. This 0 will go here 0 0, it will becomes 1. Means whether your Q is okay, so your memory is 0 or 1. Okay, so if R equal to 0, it will be 0. Output will be 0. This one will be 0. This state will be reset. Reset state. So next to 1 0. So this will become 1, this will become 0. So when any one of the input is high, output will be low. So this is 0, this 0 will comes here, 0 0. So this becomes 1. Means this becomes 1. So whether your Q is 0 or 1, memory is 0 or 1. So if S equal to 1, so the output will be 1. Output will be 1. So this case is called set case. Set case. So now next to 1 1 case. So if you observe 1 1 case, so S equal to 1, R equal to 1, both are high. So any one of the input is high, output will be low. This one also 0, this one also 0. So Q is not equal to Q bar. This condition it is not satisfying. So that's the reason. So this will be invalid state. Invalid state. Okay. So this is the truth table of SR NOR related latch. Okay, NOR SR latch. So now the same circuit I want to be implement by using NAND. By using NAND. So then if I am taking two NAND gates, same thing, same circuit. SR Q bar. So just I changed this one. Okay. So simply, okay, here Q bar Q will comes, but here Q and Q bar will come. So now if you observe what is the truth table of this one, S R QM Q bar. 0, 0, memory can be two cases will be there. 0, 1, memory can be two cases will be there. 1, 0, memory can be two cases will be there. 1, 1, memory can be two cases will be there. So now both S equal to 0, R equal to 0. So now I already told, so NAND gate, what is the single statement? Any one of the input is high, any one of the input is low, output will be high. Any one of the input is low, output will be high. This one is 1, this one is 1. So both are 1. This is invalid case. Invalid case. Okay. So now 0, 1 case. This one is 0, this one is 1. Any one of the input is low, output will be high. This is 1. This one comes here 1, 1. This becomes 0. Means it is not depends on the memory. So it is directly making your Q is 0. Sorry, your Q bar is 0. Means your Q, this 0 will goes here 0, 0. It becomes 1. Means your Q is 1. Your Q is 1. This is 1 and this is 1. This is 0. So this is set case. Set case. So now next S equal to 1, R equal to 0. So in this case, this output becomes 1. This 1 will goes here. So 1 and 1. So this becomes 0. Means Q becomes 0. Means S equal to 1. So whatever the memory, output becomes 0. So this is reset case. Set case. So next to both are 1. This is 1. This is also 1. If memory, okay, if memory is 0, so then this will become 0, 0 and 1. So any one of the input is low, output will be high 1. Means, so if you are 1, this 1 will goes here, 1 and 1. So output will be 0. Means if your memory is 0, it will be 0. If your memory is 1, it will be 1. Okay. So quite opposite this one. So this is memory state. So if you observe this circuit and this circuit looks connections will be same, but the truth table is quite opposite. So here 0, 0 case we will get the memory. Here 1, 1 case we will get the memory. Here 0, 1 case we will get the reset. Here 1, 0 case we will get the reset. And here 1, 0 case we will get set. Here 0, 1 case we will get the set. Here 1, 1 we will get the invalid. Here 0, 0 we are getting invalid. Means quite opposite we are getting. But the first memory element is NOR based latch. Okay. So this only we invented. Okay. Based on this truth table only we need to go forward. So that's the reason I need to develop the same truth table. So the same truth table I need to develop by using this NAND gate. So that's the reason we invented one more type of latch, that is gated SR latch. Gated SR latch. What they did? So NAND gate they took. So now this is S, this is R. So this is the gated. This is enable E. This is the gated SR latch. Okay. So this gated SR latch, okay, SER. Okay, this is the enable. So this is the gated structure. If enable equal to 0, S is whatever it is, R is whatever. Means S can be 0, R can be 0, 0, 1, 1, 0, 1, 1, 1. So 1, 1, anything. S, R, anything, don't care. So the output will be memory state. Memory state. How it is memory state, I will tell you. This is 0. So this is 0. This is also 0. R, no need to be worried about it. Okay. Any one of the input is low NAND gate. Output will be high. This is gate 1. This is gate 2. 3, 4. So gate 1 and 2 output will be high. 1 and 1. This 1, 1. This circuit, if I will give to this circuit 1 and 1, what we are getting? 1 and 1 memory state we are getting. Getting 1 and 1 we are getting memory state. So if you go through the truth table of this, E, S, R QM Q bar. 0 case, whatever this one, okay. So if 0 1, so it will be 0 1 1 0 means memory state. So this one is now 1. Now E is 1. E is 1. S is 0, R is 0. So no doubt S is 0, R is 0. This one is 0 and this one is 0. So then what happened? Any one of the input is high, output will be, any one of the input is low, output will be high. So this is 1 and this is 1. So this two table, if I am giving 1 and 1, so this circuit, so that is memory state. Memory state means whatever memory will be there, same value will be comes. Means whatever QM, Q also same. So this is 1 0. So next, E is 1, S is 0, R is 1. So now S is 0, R is 1. So S is 0, output will be 1. So this is output will be 1. R is 1. So enable is already 1. 1 and 1, what is the output we will get? 0 we will get. 1 0. So this circuit, okay, this circuit, if I am giving 1 0, what is it? Is reset state. 1 0, it is reset state. Sorry. This is reset state. This is reset states. Okay. So next, this is enable is 1 0 1 1 1 0. Now 1 0, if you take what we will get? So 1 0, this will becomes 1. Enable is 1 1 1. This output becomes 0. So this is 1. This is 0. This output becomes 1. 0 1. If I am giving to the circuit 0 1, if I am giving, so what it is? Set case means output becomes 1. Set case means whatever the memory, it becomes 1. Output becomes 1. Next 1 1 case. All are 1. So this is 1, this is also 1, this is 1, and this is also 1. So then 1 1 case, this is also 0, this is also 0. 0 0, if I am giving to this circuit 0 0, so this is invalid case. This is invalid. So invalid case. So if you observe this, okay, so the truth table whatever we are getting here, the same truth table whatever we get for with SR latch. Okay, so the truth table which are getting here, the same with the SR latch we are getting. So the only thing is enable extra we added. Enable extra we added. This is called the gated SR latch. Gated SR latch means by using NAND. Why we are using NAND? So we can, someone will ask that, okay, so we have NOR, right? Okay, so this is the first invented gate, right? So we can go with this only. So why we need to go with the NAND? So NAND will consume low power, okay, so my power consumption will be low and area also low, and a NAND, okay, scaling will be very easy than the NOR scaling. These all many factors are there, so those all consideration will only represent in the NAND. Getting? So this is the NAND circuit. So gated SR latch. Gated SR latch. If someone will ask what is the trigger of this one, means E equal to 1, it is triggering. Means if clock signal is like this, okay, when E equal to 1 means when E equal to high, then it is triggering. So that's the thing. So it is equal to 1, it is triggering. This is a positive level triggered. Okay, this gated SR latch, whatever I explained, so that is a positive level trigger. If it is turned on based on equal to 0, so then that is the negative level triggered. Okay, so that negative level triggered, positive level triggered, what are those things? Okay, I will tell you tomorrow. So now this is a gated SR latch. If you understand this, so we'll go with the D latch. Any questions, any doubts here? We'll go with the D latch. What is the D latch? D latch is nothing. Okay, this gated SR latch is there, right? This gated SR latch. This gated SR latch only, what they will do,
one input.
this gated SR latch only. This is enabled. So this is wait, I will change this gated SR latch only. They will add one inverter and make like this, and they will make one input. Okay, D they will make. So now what happens? D equal to 0. So S becomes 0, R becomes 1. D equal to 1, S becomes 1, R becomes 0. Means only two cases will be executed. Okay, only two cases will be executed. When D equal to 0, 0 1 case, 0 1 case. When D equal to 0, this case will be executed. So D equal to 0. So D equal to 1, this D equal to 1. So then, so S equal to 1, R equal to 0, this case will be executed. This case will be executed. So if E equal to 0, E equal to 0, so then memory state will be there. So three cases will be there. So if you observe what we are getting, so this one is memory, this one also memory, this one is reset, this one is set. This one is set. So we'll go with the D latch truth table. So we'll go with the D latch truth table. If you go to next page, so I will draw that one, D latch. So this both we should connect it to be with one inverter. So this is the D. This is E. Now E is there, D is there, Q, M, Q bar. So now E equal to 0, whatever D is 0 or 1. So 0, 1 will be there, 0, 1. So then this is 1, 0. So this case is called the memory state. Memory. If E is 1, D is 0. D is 0 means what happened? This one 0, this one is 1. This one is 0 and 1. What is we are getting? 0, 1, 0, 0, 1, 1 case. 0 means 0, 1, 0, 0. Output becomes reset. This is reset. So now next. So E is 1, D, QM, Q bar. So E is 1, so D is 1. So D equal to 1. D is 1, this one becomes 1, this one becomes 0, 1, 0 case. So this circuit 1, 0 case, what we are getting? 1, 1. Means set case we are getting. Means Q is 0 or 1. So this output becomes 1. This output becomes 1. So these are the cases. This is the memory, this is reset, this is set. If you properly observe, okay, if D is 0, output is 0. If D is 1, output is 1. So that's the reason. So this latch we call data latch. This latch we call data latch, or this latch we call delay latch. Whatever giving the signal, the same signal will be get output side with delay of these cells. So delay latch you can say, or data latch you can say. Okay, they will call in different names. So this is a D latch. Understand? Any questions, any doubts with the D latch? Any questions, any doubts with the D latch? So this one is clear. So then we'll go with the next one. So now whatever we discuss, okay, so these latches are incomplete latches. Means if two cases are there, two inputs are there, there are four possibilities: 0, 0, 0, 1, 1, 0, 1, 1. But if you observe, that is NOR latch or NAND based latch, any latch, so we are getting one invalid state. So I need to overcome this invalid state. How I need to overcome this invalid state? So then the invention of one more latch is came into the picture. how they overcome the invalid state in that. So we can see that. So now this Q they will take and connect to this second AND gate, and this Q bar they will take and connect to this first AND gate, second, third, fourth. So now if you observe all the other cases, it will be same. When come to 1, this is 1, S is 1, S equal to 1, R equal to 1, and enable is 1. So now what happens? So all are 1, it will look for Q. Q is 0. So then what happened? This one becomes 0. So this output becomes 1. And so Q bar is Q is 0, Q bar is 1, right? So this Q bar will goes here 1, 1, 1. This becomes 0. So 0, 1 case, what we will get for this circuit? This circuit 0, 1 case, what we are getting? 0, 1 case we are getting set. Yes or no? So 0, 1 case, this circuit we are getting set. 0, 1 case we are getting set. Means output becomes Q becomes 1. Q becomes 1. Q becomes 1. So next, so if Q is 1, Q is 1. Now Q already becomes 1, right? Now Q is 1, it will take. So next what happened? This 1 came to here, 0 will goes to here. This is becomes 1, 0. 1, 0, Q becomes 0 now. Q becomes 0. Means what happened? The output will be continuously toggle. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Like that, it will be toggle. Okay, so it will be toggle. And one more thing, okay, so it will not be, see, latch will not be stop until unless, okay, enable goes to the 0. Enable goes to the 0. So it will keep on checking the output inputs. Okay, based on the input combination, it will generate the output. That's the reason we will get the toggle mode. Means, so if I will go to the truth table of this one, this circuit, okay, so the truth table of this circuit is remaining all things are same in this invalid state. So we need to write a toggle mode. Okay, we need to write toggle mode. Getting? So instead of J and K, instead of S and R, so they given name as J and K. This is JK latch. This is the story of JK latch. In the JK latch only, all the 4 possibilities will be, we can go with all the 4 possibilities. This is the complete latch. This is the one of the complete latch, which will have all 4 possible cases. So this is a JK latch. So if you understand this, so the truth table is same as, okay, same as, where is this one? Same, this is the truth table for that. Same truth table. So same truth table, just to go with this. Any questions are there? So we'll discuss that one. So this is the JK latch. So now, so the next T latch. T latch is nothing. T latch, what they will do? They want toggle state. T latch means toggle latch. So they want toggle state. They will add like this. J and K, they will make both are 1. This is T. If T equal to 0, memory state. T equal to 0, E equal to 0, C. Without both connecting, that is JK. With both connecting, that is T. Okay. So D, so with inverter, we will connect to R. But here both we will connect same signal. So now what happens? Now what happens if you observe, okay, if E is there, T is there, QM, Q bar. So now E is 0. E is 0, whatever the T, so 0, 1. So this is 0, 1, this is 1, 0, this is memory state. memory state. If E is 1, T is 0, T is 0, this is 0, 1, 0, 1, 1, 0, this is also memory state, memory state. So next, E is 1, T is 1, T1 means J is 1, K is 1, toggle state, okay, this will be toggle. Toggle means one time it will output will generate 1, next time it will 0, next time it will be 1, like that it will change. That is the toggle mode. So the latch have one problem is until unless enable is 1, it will keep on checking the inputs and generated corresponding output. So that will call the race around condition. Okay, this is the one of the problem we have in the race we have in this is the one of the problem we have in this this latch. Okay, whatever latches are there, all the latches we will have the race around condition. Keep on generating the output. Okay, with respect to inputs. Okay, it will generate keep on outputs like that. It will be generate and it will do. Getting? Understand? Any questions? Any doubts here? Any questions? Any doubts here? Guys, at least chat. If you have a questions or doubts, at least
No, sir, no doubts.
Okay, okay. So what we started? So I will recall, just focus. So I will recall, just focus what we started. So we started it, okay. So SR, okay, NOR based SR latch, NOR based SR latch. This SR latch, okay, whatever this SR latch output we already knows. This SR latch output is like this. First is memory state, reset stage, set stage, and invalid. Okay, these are the stages we are getting. So now this is the first memory element which we invented become with a different process. Okay, one evaluation is there. Okay, step by step, 4-5 steps. After that, we get this circuit. This circuit output is this one. So I want to make the same circuit by using the NAND. So I implemented same circuit by using the NAND, but the truth table is quite opposite to the NOR truth table. So the NAND SR latch, okay, so is opposite to the NOR. So I want to implement, okay, I want to replicate this same truth table in a NAND. What I did? So I go with the gated SR latch. This is the gated. So when I'm going with the gated SR latch, I'm getting the same table whatever is there in the SR latch, but one extra input we got, that is enable. That is enable. So that one only clock enable they will say. Okay, clock enable. Based on the enable signal, if enable signal is 0, so then output will be 0. So means this latch is positive level triggered. That's the reason enable is 0. So then output will be memory state. Okay, enable is 1. So then based on the inputs S and R, so it will be generate the outputs. Okay, so now, so you've seen the SR latch, gated SR latch. Okay, same it is like a NOR SR latch, which is we invented first time. So now, so this S and R, so we are giving separately. If I will connect these two, means so S is I am directly giving, R I am giving with inverter. So now what happens? R I am giving with inverter. So then what happening? So it is generating S equal to 0, R equal to 1 when D equal to 0. When D equal to 1, S is becoming 1, R is becoming 0. Two cases we are getting. Yes or no? So that truth table, if you observe, so this is the truth table of that. E is 0. So whatever D 0 or 1, it will be memory state. E is 1, D is 0, output will be 0. That's the reason we are calling this is as a D latch. So D is 1, so output will be 1. So memory, whether memory is 0 or 1, both the cases output will be 1. So that is the static case. Getting? So this is the D latch. So now in this all the latches, whatever if you are see SR latch, D latch, okay. So in these two latches and the previous whatever NOR gated NOR based SR latch also, all the latches will have one invalid state. Will have one invalid state. To overcome this invalid state, okay, what they did? So this Q bar, Q is connected to this first gated, second gated SR latch, and this Q bar is connected to this first gated SR latch, first gate to NAND gate. So then what happens? So this both, so J is there and K is there. So when J is equal to 1, K equal to 1, so what happens? Both this one becomes 1, this one 1. So it will depends on the memory. Memory is 0. So then the outputs will be different outputs will be good. If memory is 0, so what happens? This one is 0. So this one is becomes 0. So this output becomes 1. Means what combination we will get here? So 0 1 combination we will get if memory is 0. If memory is 1 1 0 combination we will get. Because of that, okay, the output continuously toggle until unless enable goes to the 0 state. Continuously it will toggle. So it is toggling. So with when it is toggling, J equal to 1, K equal to 1, it is toggling. Okay, that's the reason if I want to be generate any clock pulses, I can use this toggle latch. Okay, how I can use the toggle latch means, okay, I can make simply, so J also I'm connecting to T and K also I'm connecting to T, and I'm giving as input 0. So both either 0 it will goes or input 1, both it will goes 1. 0 case it is memory, 1 case it will be toggle. This is the toggle flip-flop. Toggle latch. Sorry, this is a toggle latch. So whatever we discussed, these are all the latches, okay? With enable equal to 1 only, it is turn on. So these are the positive level triggered latches. Positive level triggered latches, these are. So these are the things, okay? So this is the concepts. So go with these things. And one more point, main point is, so in the latches, what happens? It will be checked. See, now output is 1. This output will be again comes to here and it will be generate corresponding outputs. Okay, it will generate it again the inputs. So again it will loop and now output becomes 0. This 0 it is will comes again and it will generate. Like this, it is keep on checking until unless this enable becomes 0. This enable becomes 0, it will checking like that. So that only will call the race around condition. To overcome this race around condition only, we will go to the flip-flop. Okay, we will go to the flip-flop. So now whatever we discuss is all the latches, SR latch, okay, so D latch. So whatever these latches we discuss, these all will be stored 1 bit. Getting? These all will store only 1 bit, single bit. Either it will store 0 or either it will store 1. Getting? So most of the people latch will store single bit, flip-flop will store double bit. No, latch also store single bit, flip-flop also store single bit. But the difference where it will comes means latch have one problem that okay, raise around condition, keep on checking the outputs, checking the inputs and generating the outputs. Keep on it will do that. But flip-flop is not like that. When the trigger will happen, okay, when flip-flop comes, okay, so it will be positive trigger or negative trigger. When this level, this whatever this time only it will turn on, other time it will be turned off. This time will be very less, okay, it will be turned on and it will generate the output and it will goes to off. That's it. So that's the reason we will go to the flip-flops. Okay, so now what is the difference between latches? What is the difference between flip-flop? Okay, what is the positive level triggered latches? What is the negative level triggered latches? Positive edge triggered flip-flop, negative edge triggered flip-flop. These all things we'll see in the next class. Any questions, any doubts are there related to this or last class? So you can ask. You can ask. Otherwise, we'll stop here. Any questions, any doubts? These are the things. Go with these things. recall these things. So we'll discuss in the next class, we'll discuss related to these latches. So sorry, related to flip-flops we'll discuss. So the same, how many latches are there? So what are the latches we discuss? SR NOR latch we discuss. So SR NAND latch we discuss. So then SR gated NAND latch we discuss. After that, this will be changed. Everything will be gated only. So then D gated NAND latch. So then same JK gated NAND latch. So then T gated